dV. Okay. Next, so there are few theorems in moment of inertia. Actually, not few, only two theorems which are there in moment of inertia. So those theories, if you understand, okay, very well, then the problem solving becomes very simple, very simple actually. Okay, so perpendicular axis theorem. So according to this theorem, it states that the moment of inertia of areas about an axis perpendicular to the plane of the axis is equal to sum of the moments of inertia about two mutually perpendicular direction in the same plane. So whatever, okay, this definition refers to or applicable for polar moment of inertia, because we did calculated the we did actually calculation of izz, okay, in the previous slide or one or two previous slides, right? Previous in the last slides we discussed. So izz is nothing but moment of inertia about an axis perpendicular to the plane. Okay, so actually this perpendicular axis theorem is meant for finding izz, and according to this theorem, the moment of inertia about an axis perpendicular to the plane of the axis will be equal to sum of moment of inertia about the two mutually perpendicular axes in the same plane. Okay, so the meaning is, so I had drawn, I mean, in the previous slide, I had drawn one rod with x-axis and y-axis, right? So let's say this is okay, this is x-axis and this is y-axis, and there will be z-axis over here. Okay, so if you want to calculate moment of inertia about the z-axis, that's nothing but izz. Okay, according to theorem, okay,
Ixx plus Iyy.
plus yes, Ixx plus Iyy. That is the required solution. This has to be proved. Okay, so izz is equal to Ixx plus Iyy. This is only a theorem. A theorem is the one which should be proved, right? Then only it is accepted, right? Somebody can say, okay, something, but he has to prove himself so that others can believe, right? So this is a theorem. We need to prove that, right? So izz is equal to Ixx plus Iyy. Now let us prove that. Proof for perpendicular axis theorem. So let us consider a small, I mean, some area, okay, some irregular area, and let this be the small elemental area A, and let total area be capital A. As usual, let us consider x as the distance of elemental area from y-axis, and let y be the distance of the small elemental area from x-axis. Okay, and as we know, the moment of inertia about z-axis is equal to summation of r square into dA, right? All of you agree, right? Because r is the perpendicular distance, I mean, the distance from the small elemental area to axis. So definitely second moment of area, which is nothing but moment of inertia, okay, or it is also called as polar moment of inertia, is equal to sigma r square into dA, right? So now with this starting as this equation start, okay, we should prove that. Now let us see. Okay, what do you have any clue about bringing it x and y here, bringing in this instead of r? How can you bring x and y values here? Can you apply Pythagoras theorem?
Yes, sir.
Yes, right. So we know that r square is equal to
X square plus y square.
Y square, right. So therefore we know that r square is equal to x square plus y square. Therefore, if you substitute the value of r square there, it will become in summation of x square plus y square into dA. Now we can separately consider them each term, like sigma x square into dA plus sigma y square into dA. And what is x square into dA? And what is sigma? Correct. So sigma x square into dA is Ixx. Sigma y square into dA is
Iyy.
Is it so? Is it so? One more time. Think one more time. So there only you go wrong. So see, Ix moment of inertia about x-axis means what is the perpendicular distance?
Iyy is I. First one is Iyy, sir. First
yes,
term. Second
yes,
one is
yes, yes. So you should be very, very careful. Okay. So Ixx meaning is second moment of inertia about x-axis. It does not mean that perpendicular distance is x. Okay, Ixx is nothing but second moment of area about x-axis. So if you want to calculate the moment of anything, you need perpendicular distance, and the distance from here to here is y, not x. Okay, so this value becomes Iyy, and this will become Ixx. Okay, so that's the reason why this is Iyy and this is Ixx. You should be very, very careful. So now one more to remember. So Ixx is equal to sigma a y square. Okay, Iyy is equal to sigma a x square. Okay, so that's what you should do it. So hence we proved this term, right? So it was nothing but it was said that summation of Ixx and Iyy, hence it is proved. So that's very simple derivation, and it may be asked for 4 to 5 marks, or sometimes 6 marks can also be asked. Okay, any doubt? Anybody? Yes, reply. Kannad, are you there?
No, sir. Understood.
Understood, right? Let us move on. Okay. So next is parallel axis theorem, and parallel axis theorem is the one which is really, really used to calculate the moment of inertia in problems. Okay. So this is very much important theorem. So all of you listen and watch carefully. So it states that the moment of inertia of a plane area about an axis in the plane of the area is equal to sum of the moment of inertia of the plane area about a parallel central axis and product of area and square of the distance between them. Okay, so it said that moment of inertia of an area about any axis, some arbitrary axis, for example. Okay, so about any axis is equal to sum of moment of inertia about its own central axis and a product of area and square of the distance between them. See, until unless I draw the sketch, you will not understand this statement. So now let us have this figure. Okay, so where you have this area, and you see here there is a small elemental area which is A. Okay, and you can consider the total area as capital A. Now there are two axes here. Actually, our aim. Okay, let us consider some arbitrary axis AB. So we need to calculate moment of inertia about this central. I mean this axis AB, IAB. Okay, and that is our objective or aim. Okay, so let us consider one more axis. Okay, which is passing through this centroidal axis. Okay, so let G be the centroid of this given figure. Okay, let G be the centroid of this given irregular figure, and let us pass an axis through this centroid, and hence it is called as centroidal axis. This is called as centroidal axis. Okay, so centroidal axis, right? So according to the theorem, moment of inertia about AB, that's nothing but IAB, is equal to sum of moment of inertia about centroidal axis, that's nothing but IGG, plus product of area and this is the area, capital A, product of area and square of the distance between the two parallel axes. Let YC be the distance between two parallel axes. Okay, so then IAB is equal to IGG plus area into YC square. Okay, so this is the definition of our theorem. According to theorem, it is the statement actually. IAB is equal to IGG plus IA into YC square, where IGG is moment of inertia of this area about an axis passing through the centroid. Okay, that's all. That is different, and another axis is different. So there are two moment of inertias here. One is moment of inertia about its centroidal axis, and another is moment of inertia about its outside axis. Let's say it's AB axis. Okay, So there are two moment of inertias, but there is a relationship between those two moment of inertia. That is given by IAB is equal to IGG plus area into YC square. Okay. So this has to be proved. So now in order to prove that, now let us consider the same thing, same figure here. So can anybody tell me what is the moment of inertia about AB in terms of second moment of area in terms of this small elemental area A? We had the formulas, right?
So, repeat, sir.
What is the moment of inertia IAB in this figure according to the definition of moment of inertia? Second moment of area, right? A moment of inertia, nothing but second moment of area. So now what is the formula? What it should be? So IAB is equal to
y plus yc whole square into a.
Yes. No. That is actually in terms of IGG, but in general. So just forget about this central axis. Okay, you just forget about the central axis GG and all. You have only this elemental area and this axis. You remember? Okay.
Sir,
You don't have any.
integral y square dA plus.
Yes. Okay. Integral y square dA, isn't it? But what is y here? Y is nothing but actually the distance from here to here, right? Okay.
Yes, sir.
Because IAB, we need moment of inertia about this axis. Okay, so we need to consider that perpendicular distance from here to here. Let's say we will consider it as some capital Y. Okay, okay, some other term. Let's say Y dash. Okay, because already we have taken some Y as the distance of this small elemental area from central axis. Okay, let us call it as Y dash. Okay, therefore okay, it may be let's say y total. I'll take it. Okay, y total. So instead of dash, let's say y total. So what will be the definition? Integration
Y total square.
YT square into dA or small a. Okay, whatever. So into dA, right? This is the definition. That is what will be there here. So we know that, and so we know that first moment of area will be 1 second. So that's how you can get it. Finally, you will get that thing only. So yeah, right. So first moment of area will be, because as I told you, A into the total distance yt is equal to y plus yc. Therefore, that is the value. Next, second moment of area will be equal to A into y plus yc the whole square, or other words, A into y square is nothing but y plus yc the whole square only. It will become. Now, okay. So you can either consider in integral form or in summation form as well. Okay. So now here IAB is equal to sigma A into y plus yc square. So you expand y plus yc square, A plus b whole square, A square plus b square plus 2ab. So y square plus yc square plus 2y into yc. Now next further, you try to segregate each term separately. So sigma A into y square plus sigma A into yc square, okay, plus sigma A into 2 y into yc. Now, okay, so what is sigma A into y square? According to definition, it is yeah, right. It is second moment of this area about what? IGG, right? So I mean GG axis. So therefore, this becomes IGG. Now, what is this? Sigma A into yc square.
So the that thing. Parallel axis theorem, that other term was there, sir.
Sigma A into yc
Sorry,
square.
sir. No.
Let us move on. I'll let you know. So there is no value now actually. So you just keep that one. So you take this yc outside. Okay, yc square outside. Keep this sigma A outside, because this yc is constant, right? It is not changing. Okay, from this axis. So it's not having any value. So only you will have sigma A only. I mean, yc is a constant value. It's a fixed value. Okay. So it does not change every time, because centroid will be fixed. Therefore, yc will be fixed. So keep that yc square outside only. But the into sigma A. What do you mean by sigma A? Capital A. Okay, so that becomes A into capital YC square. But there is, what about this remaining thing? Let us see. So this becomes, so IgG plus YC y square A. So all that we have, we need to have is these two terms only. But what is this extra thing? Let us see what actually that is. Okay. So it's nothing but 2 into YC into sigma A into Y. Okay. So let us move on further. You know what I'll do? I'll multiply A over here and divide it. Multiply and divide it. So what actually happens to A into 2YC into sigma AY divided by A, right? So now you can see I have just segregated this A into Y divided by A. So now what can you tell me? What is this term summation A into Y divided by A?
X bar.
Actually speaking, okay, X bar is only, yeah, so it's nothing but uh, Y bar, right? Why? Because in centroid it's not X, Y and X values will not change. It is same only. So it's nothing but Y bar. Okay. So this is nothing but Y bar. So it's nothing but summation of all Y bar. Okay. Actually, A into Y divided by A is Y bar. So sigma Y bar. We know that in case of
Sir, what is Y bar, sir?
Y bar, right? Centroid distance in the previous unit we have found.
Yes, sir. Yes.
Okay, A1 Y1 plus A2 Y2 plus A3 Y3 divided by whole divided by capital A. So this is Y bar. And sigma Y bar. What do you mean by sigma Y bar? Sigma Y bar is nothing but you can see here represent the distance of centroid G from the central axis GG. Okay, see here in this previous figure. That was center Y bar. Y bar here because actually this Y bar lies over here only. Okay, with respect to central axis. So since centroid lies on the x-axis, what is Y bar equal to? Y bar is equal to 0, right? See,
Yes,
we had many number of problems where the centroid was lying on the axis of symmetry x-axis. Okay, in those cases, okay, if let's say for example circle. So in that circle, centroid lies over here, and therefore if you consider axis, okay, let me just take axis over here. So x bar will have some value, but what about Y bar? Since the centroid is lying on the axis of symmetry, so Y bar will be equal to 0. Same in the case of, same is this in the, same is that in the case of present problem. So here this whole thing is Y bar, and sigma AY divided by A is Y bar, sigma, okay, and that Y bar in this case is 0. Therefore this entire term will vanish. So only remaining thing will be IAB is equal to IGG plus A into Y square. Okay, everyone, this is very important relationship which you need to remember. Okay, and don't forget at least till you will complete your exams. Okay, because if you are a mechanical engineer, I would have definitely told you have to remember for your for your entire life. But being a computer science engineer or CSC people, so actually speaking, you may not need this if you don't want this. But if you really want this, I mean, if you want to select this field, like if you are developing something in mechanical parts or something like that, definitely you also have to remember in your whole life. But for examination purpose, if you are only studying about that, so you can at least you remember till the end of the exams, right? Okay. Any doubt?
No, sir.
Any doubt? It
No,
was okay. So I started at 4:15. Now it is 5:06. Okay. So I think I'll stop over here. So otherwise it will be too much. Okay. So in the next class, actually, we will derive the center. I mean, the moment of inertia of rectangle. So the same way we did centered of rectangle, triangle, okay, semicircle, all that, right? So we will also be having a moment of inertia as well. Okay, So actually it would take another 30 minutes. But anyhow, let me not extend because it's a fresh topic. I will either record the video and post it. You can watch. I think that is the better option because we need to proceed to the problems directly. Okay, but for before you attend the next class, all of you should complete the watching of that video, and I'll be posting some quiz in the next um, class. Before class, I'll be asking a quiz. I mean, I'll be giving a quiz on this moment of inertia, and then only I'll be starting the problems. Okay, so which do you prefer? Shall I cover the derivations on recorded video and post, or directly should I take the class? Hello, replay.
Recorded, sir.
Recorded will be better, right? Anyhow, because physical class will need so much of time, attention, isn't it? And attendance also is required, isn't it? So what I'll do, I'll record the video for derivation of these moment of inertias, okay? And I'll be posting it on to the CEDMS website. You can you can watch directly or download and watch, okay? Yeah, anybody, any doubt?
I posted on YouTube, sir.
Yeah, that's whatever I post it on YouTube, same thing will be sitting on CEDMS website, okay? Because that is how directly, I mean, one link, okay? Any doubt, anybody? Understood, sir? Very clear. If I am not clear, you can just ask me any doubt, I'll clear. I'll make it clear. So I hope that everyone have understood the things. Okay, I will post the video of derivations of centroid. I mean moment of inertias, and we'll start with directly the problems. Okay, one more thing. When is your exams? I mean, MSc 3 is starting tomorrow, right?
Yes, sir.
So tomorrow you have maths.
Yes, sir.
And next Saturday?
Chemistry.
Do you have a test on Sunday as well? Hello?
No,
Aniruddha?
sir.
No. So, okay. So, what we will do, I will not disturb you. Okay, tomorrow is 26, 27, 28. Okay. So, I will not disturb you tomorrow, right? So, on Sunday, we will have two classes. Will that be okay?
Okay, sir.
So we'll have to have two classes.
Fine.
I'll be covering all the problems there only, moment of inertia problems. Okay, I'll try to do as many as possible. Maybe 4 problems. I'll
Sir, take class on Saturday, sir, because Sunday is free. So.
Is it okay Saturday? Hello?
Yes, sir.
Yes,
Peace,
sir.
sir. Peace.
Okay. Then Saturday only after the test I will take the class. Okay, so then it will be okay. Saturday one class, Sunday one class, and that will be I'll be winding up there. So more classes I'll record and I'll put for more problems. Okay.
So
Yes.
will derivatives come in exams?
Yeah. Pardon?
Okay. Full proof means with the statements and all, or direct on.
Yeah. No. You there are exam in the exam you'll get the proofs as well. I mean you need to prove. I'll just show you. Is this visible?
Yes,
Screen.
sir.
So what here you will be doing is actually speaking, if you know to derive centroid, and definitely moment of inertia, derivation of moment of inertia is not a big deal actually. So it's same way you will have the equation actually dA into y square will be there, and you will be considering elemental area, and you will be considering perpendicular distance as y, and you'll be just substituting the value of y and applying the limits from minus d to plus d by 2. Okay, minus d by 2 to plus d by 2. Anyhow, I'll be posting it posting this video. It's very simple. Okay, if you just remember this formula, dA into y square, that's fine. Okay, and the rest of all is just application. I mean, finding the dA value, dA value and finding the y value, substituting it and integrating between the limits. That's all you will have. Okay. So very simple it will be. You will have actually 4 standard derivations. One is moment of inertia of a rectangle, next moment of inertia of a triangle, and moment of inertia of a circle. Okay, and the moment of inertia of a semicircle will be there actually, semicircle and all. will be there, and that they will be given directly. Okay, you need not prove. So usually 3 derivations: circle, triangle, and rectangle derivations will be there. Understood?
Okay, sir.
Okay. So then I will be ending the class here. So we will meet on Saturday. I'll be posting this recorded video of both the, I mean, whatever we did till now, and I will be completing the derivations of rectangle, triangle, and circle. I will be posting it on the CEDMS website or YouTube. And I insist all of you to actually, I don't recommend that. Okay. Because actually speaking, I will not be, I mean, I will be posting the videos, some oftenly. So what you do, you just subscribe to my channel, so that whenever I post a video, you'll be getting a notification, and immediately you can keep watching, and we'll have a follow up. Okay. I insist you to do that. So, and it's not a compulsory thing, but if you want really, if you want to track the classes, I mean recordings, you just put it, I mean subscribe it, so that you will get the regular updates. Okay, will you do that?
Okay.
Yes,
Okay,
sir.
okay.
Yes, sir.
Yes. Immediately you do it, so that I'll see. Now I will have a count. Let me see how many it will increase. Then I'll let you know. Okay. Okay. Thank you, students. So if that's the case, I am signing off. Bye.